Okay, picking up where we left off, or somewhere around page 396, talking about the Type 1 versus Type 2 virtualization software. So, Type 1 essentially installs first, and therefore all of the all of the guest operating systems can talk directly to the physical devices. So they're typically faster. You would do that in a server environment. For example, I typically wouldn't have a web server up here as a Type 2. The Type 2 guys they're okay, they're fantastic, and I use them an awful lot. But these are my way of thinking. These are kind of temporary. I fire up a Type 2 and I shut it down. I don't ever have them running 24/7. If you're going to have them run 24/7 and they're going to be doing some serious work, well, then they really ought to be the Type 1 where this virtualization layer actually squeezes in right there. And so all operating systems go through the virtualization. There is no host one that can talk directly, and none of them, in this case, this guy can talk directly to the host, and everyone else has to go through the virtualization. That's not the way it works. If it's a bare metal Type 1 kind of a thing. Okay. Security concerns. Yeah, there's a bunch of issues with this. One is, I told you this guy has its own virtual memory, and this guy has its own virtual memory, and this has its own virtual memory. But reality is, they're all using the same memory. I mean, in real life, right? So this virtualization layer has to be really, really robust. The security here is a little complex because this guy has to get that information, and then it has to keep them straight. So, yeah, you're adding more complexity to a system that's already pretty kind of complex. So, yeah, there's a possibility of making some mistakes. Shared network components. I only have one network card down here at the hardware layer. One. So one thing comes in, it goes up to here, and it has to get divvied up between these guys. So is it possible that this virtual device is actually receiving a broadcast from this guy over here and this guy over here? Yeah, it's possible. Because there really is only one network card in this system. I don't have 4 network cards in this scenario here. So again, a little bit more complexity. And the other thing is, if the virtualization is happening here, let's say this guy here got a virus on his Windows 2012 machine. Well, you might say, well, I've got antivirus right down here on my Windows 7 machine. Sorry, this Windows 7 antivirus can't see inside this guy's files. So, not only do you have to install an operating system on each one of these guys, you also have to install your antivirus stuff on each one of these guys. So if I have to install an operating system, I got to install all the applications over again. So Microsoft Word over here, I can't get it from over here, so I install everything. It's just like you went and bought 4 brand new computers. You have to install the operating system on all 4, all the applications on all 4, all the utilities, all the antivirus, all that stuff has to be done. Now, what if you don't have licenses for all those? Well, okay, now you're in trouble. Now you need to go spend some money, right? Because there's no pass. There's kind of sort of a pass that Microsoft decided to give you if you have one additional guest operating system. They'll actually allow you to install the operating system and some of the application software. But it's a scenario like this, no way. You got to pay. Okay. So next they talk about warehouse scale. On page 397, they talk about clustering computers together, and clusters of computers is the term that I typically use. I never use their kind of thing. And so here's an example of some of the things that you can get out of this. So here's a bullet list. So why would I ever want to go in and do a cluster? Well, performance per dollar. So warehouse cluster. If you're a big business and you're spending lots of money, you can actually get more performance per dollar if you cluster a bunch of things together. Performance for joule of energy. A lot of these companies are getting very much aware of their energy footprint and their air conditioning requirement and the utility bill they have to pay. I'm a green company and I'm trying to to do the right thing. So if I have a big data center that has all these things clustered together, I can get more performance per amount of kilowatt hours of energy. More reliable. If I have a bunch of clusters, if one goes down, I rarely would know. The request level parallelism. So let's say, for example, I'm trying to solve an equation. I don't just ask this one computer to solve the equation. I go to this one computer that breaks up that equation into 100 pieces and sends out the data to the 100 machines, and they all work on one piece of the equation, and then they feed back the answer. So parallelism. In handling device failures. So lots and lots of servers, and if one of them dies, fine. I'll just go replace it one day because I don't much care. I got so many of them on there, it doesn't really matter. Here's a picture of what one looks like. I'm going to zoom in a tiny bit if I can get there without going nuts. Okay, so here is a single computer, a server. So this server has 16 gig of RAM, 20 gigabit per second network, and it's got a 2 terabyte drive, blah, 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 blah. Okay, so here's its processors and its disk. And then you put this into what's called a local rack, and there's 80 servers in a local rack. So this local rack has 80 of these guys in it. So this is probably a 19-inch rack. A single 19-inch rack has 80 of these individual servers in there. And then you have a data center that has 30 of those racks. So yeah. So now combined, I have 30 terabytes of RAM. Isn't that pretty cool? And 4.5 petabytes of storage. So it just stacks, one CPU into one rack and one rack into 30 racks. So now I've got lots and lots and lots of computers running for me. Cool. All right. In the old days, they use shipping containers, like a Connex container, a 40-foot long Connex container, if you're familiar with those things. And the way it's kind of odd. The way they built these things is, they opened up the sides and put all these servers in and then button things back up with louvers on the side for air. And quite frankly, there wasn't even room on the inside of this thing for a human to walk by. If you had to do some work on it, you basically pulled the sides off, pulled everything out, did all the work and put everything all back in there. Because it was so tight in there that you actually couldn't put a human inside the container with all the stuff in it. For some reason, I don't really know why, that model is not really being used much. Microsoft used it for quite some time, but a couple of years ago, they quit using the containers, and now they're just sitting on the floor in a giant warehouse kind of a thing. So I don't know what caused them to not do that. Okay, so yeah, the Microsoft data centers. There's a really cool YouTube video that I have a link to that you might want to just take a peek at, because it's got some really cool. I'll admit it's a commercial. Okay, it's a commercial, but they talk about all the reliability. They talk about the design. They talk about the design of those containers and stacking those containers in their Chicago area. So it's kind of a dated video, but it's still pretty good. Okay, cool. The next thing to talk about in the book is cloud computing. Dun, dun, dun. And so the real thing about cloud computing, really, the real thing is, let's say, for example, I've got me a data center like this, and I'm not really running it at 100%. I mean, I don't have that much computing going on. And so during my off hours, maybe I can lend it out to someone else to help pay down the cost. Wouldn't that kind of make sense? So I can recover my cost by allowing other customers to use my excess capacity. Wouldn't that make sense? That's basically what cloud computing is all about. Is I've got a data center someplace, I'm using it, but I built so much capacity that I can just let other people use it. And I do this, of course, so I can make money. NIST has a document we're going to go through, the 800.45, and I'm just going to go through it kind of rapidly because it just lists the requirements, for example, the characteristics and things of that nature of what cloud computing typically is. So, They talk about the characteristics. First, it's called on-demand self-service. So typically what that means is, if I want to make a change or add a new thing, I can go on myself. I can log into my account on cloud computing and fire up another server. I don't have to call anyone. I don't have to ask permission. As long as my credit card's good, then I can go in there and fire up a permission, reboot a server. I don't have to ask anybody because it's all self-service. Pretty cool. Okay. Broad network access. I mean, clearly these things are designed to be operated over the network. Otherwise, they wouldn't work at all. So, yes, there's usually huge network pipes going to these data centers, and I can reach them anywhere in the world. Resource pooling. This guy has 30 terabytes of RAM. I probably don't need all that, so I can pool my resources and divvy that out to different customers at different prices. I get, oh, you want 16 gig of RAM, that'll cost you this much. Oh, you only want 8. Kind of cool. Rapid elasticity. This is the most important feature. Should I repeat that for the emphasis for future test questions? Elasticity is the most important feature of cloud computing. And the reason is, it allows me to scale up or scale down my requirement. Let's say I'm a seasonal business. I'm doing Halloween decorations, or I'm doing fireworks, or I'm doing tax prep. Whatever it is, some sort of a business that has a seasonal peak, I can go into cloud computing and turn up the amount of CPUs and turn up the amount of RAM for a month. And then when my peak is over, I turn down the number of CPUs, turn down the RAM, and I pay significantly less. That is elastic computing. I can stretch and grow as my need arises. And during my peak period, I'm not paying the same amount as if I was in the non-peak. Now, contrast that to doing stuff at home or in a business. Okay, in a business, I would basically have to buy the number of servers that need for my peak. I mean, I really have no choice, right? So I say, well, I need 6 servers because that's how much I need, for doing my tax prep service in February. I need 6 servers. So you go buy 6 servers, and then June comes and you're using 2 of them. Now, you bought them all, but you're really only using 2. That's kind of sucks, huh? So, cloud computing makes that go away. I can say, I want 6 servers this month. And at the end of that month, I want 2 servers. And you just twist the knob up, twist the knob down. And as long as your credit card clears, you're in good shape. Okay. Measured service, pay per view. Essentially, you get charged by, how much you use. Kind of cool. Access. There's a thing called a private cloud. Okay. But the problem with the private cloud is if I have to pay for it all, right? If I have to pay for all of these guys, well, then there's no cost sharing, right? I mean, one of the real advantages, all the rest, yes, I can ramp up and ramp down, but if I'm paying for it all, why would I ever ramp down, right? The whole point of cloud computing is to be elastic and have me charged more or less depending on what I need. If it's a private cloud and I have to pay for the whole blessed thing, I would have no incentive whatsoever to turn the knob down. I have to pay for it all. So that's kind of dumb. A community cloud. This could be people, a particular industry, or perhaps, a bunch of accountants get together and have a cloud, or, engineers get together and have their own little thing and everyone chips in some money. That kind of works. Public cloud, now that's the one that most people are familiar with. There's 3 major manufacturers that do this. It's Google, Amazon, and Microsoft. Those are the 3 big, public cloud people. And you just give them money and presto change, you're up and running. And then a hybrid, of course, is any combination of those other categories. Okay. We'll stop this, and I promise we'll polish this off in just a few more minutes. This is a good place to stop.